Hey everybody, what's good? Just back with another stream, 2 streams in 2 days. So gonna pick up where we left off yesterday. Look at the fungible token tutorial on the onflow docs. So this one, I kind of realized yesterday that I spent a lot of time explaining things and didn't do the greatest job explaining them. So I'm probably gonna go through this tutorial a little bit faster. We're gonna work with a little bit more advanced stuff, and we're going to build off of a lot of the things that we learned yesterday. So it will give me a good chance to recap any of the things that I feel like I might have missed or didn't explain quite clearly. And similar to yesterday, this is just a quick run through. I definitely recommend going through the tutorials by yourself at your own pace and making sure that you understand everything that you read. This article is fairly long. It's nice because it actually shows some differences between writing a contract in Solidity and Ethereum and how it works in Flow. The other thing that I kind of didn't mention yesterday about doing these tutorial lessons is when you're reading these things, I'd strongly recommend coding them by hand. Just going through and playing with the playground examples is great, but when you put some time between your initial run through and trying to write some code, not a lot of that's going to stick. So if you go through each line and actually walk through the tutorial article and kind of write it out from scratch, it'll help sink some of those concepts in there, and it'll also help with things like muscle memory when you're going to write the code from scratch, staring at a blank canvas, things like that. So just a little tip there. It definitely worked wonders for me. I've gone through these tutorial examples about 2 or 3 times, and started just like that, where I was reading the articles and writing the lines out from scratch as opposed to just working from the playground examples. So on that note, let's go look at the playground example and just play with the code. So for this example, this is where things kind of get more exciting because you get to actually create a token. So in this case, we're going to create something kind of like an ERC20 token, so like a basic attention token or something that you'd see on Ethereum. These fungible tokens just basically mean that one token is equal to one token. There's no differences between the tokens. Each token has the same amount of value. So this is a cool segue between kind of a basic hello world example like we dealt with yesterday and more of a real world example of how to use smart contracts in the wild. So not quite as deep as we're going to go in the next fungible token lesson, but it's a good step. So anyways, to start with, we're only going to create one contract for this example. It's going to be a fairly big one, but most of the contract is actually just some comments from the team to help understand what's actually going on here. So let's get to it. To start with, we're going to create a public contract. It's a fungible token. And the first thing we're going to do is create a total supply field for the contract itself, and this just keeps track of the amount of tokens that are in existence. So all tokens that are minted are going to increase this total supply. All tokens that are burned are going to decrease this total supply. You'll notice that we're using the keyword var here instead of let, like yesterday's example, and that's just because the value of the total supply will change over the course of the contract's lifespan. So it's not a static or a constant field that we don't want to change. So heading down to line 24 here, we're going to see our first kind of new thing, and this is a resource interface. So these are super cool. They kind of serve 2 purposes. So yesterday's example, when we were linking to a capability and borrowing a reference, we were just borrowing a reference to the entire resource. But with a resource interface, we're actually able to specify which methods and fields the user would have access to. So this interface just exposes the withdraw method. It just includes a definition and pre or post conditions, which are conditions that will run before or after the method to double check some rules and either allow the method to proceed or revert the transaction so that no resources or assets have changed hands. So the cool thing about this is, as we'll see later on, you can actually pass out references to interfaces directly, which really gives you a lot of control over who has access to what. So this is where you get to kind of start divvying up users' access levels and kind of specifying what they can actually do with the code that you've written. The other cool thing that these interfaces do is when you're defining a contract, or when you're building a resource that uses one of these interfaces, your resource has to contain the fields and methods specified in the resource. So just as a quick example of what I mean, if I remove, or if I comment out this balance field and try to deploy the contract, well, the balance field is required for this balance interface. So when I deploy, I'll get an error message, which is just saying a lot of things, but basically the rule of thumb here is that we don't have the balance that's required by the interface that's being used by this vault resource. So just a quick example of the other kind of dev tooling feature for interfaces. I'm gonna do that a lot by hitting save. So in a roundabout way, like, the interfaces kind of have two main things that I've noticed so far. So in terms of like divvying up access, lending out capabilities, you're able to specify who gets access to what with an interface. That's kind of the main features I've seen it used for. And also on the developer side, you can specify fields and methods that the resource that is going to use the interface should actually have, which is kind of a nice thing when you're writing the code. Sometimes you'll forget to add something you need, and the code won't deploy. In VS Code, you'll actually see an error message before you try to deploy the contract. So just little developer tooling helpers that I love. So anyways, just to explain this method, the withdraw method is public. We're using our fun keyword for function. The identifier is withdraw. We have one argument. Each argument uses a label as well as a type, and it's going to return a vault resource. So this little @ symbol here, that just tells us that we're dealing with a resource. Again, just kind of expanding on yesterday's stream, resources are special. I didn't really do a good job of explaining that, so I think, like, in a nutshell, the special thing about a resource versus just a typical object or struct is the fact that you're basically adding some physical limitations to a digital asset. That's the nicest way to kind of think about it. So when you see us using resources in Cadence, you're seeing us have to almost physically move this resource from one location to another, and it's actually like moving around a chunk of something, like a physical chunk of something. So the way that we specify that in the code and kind of differentiate that is either using the move, that little arrow symbol, or the @ symbol in the type declarations up here. So just a quick recap on what resources are and why they're important. So otherwise, this method that we're just seeing, like, we're not actually seeing the full definition here, but it's also going to have to include a post condition, and it's just going to check the balance and make sure that it is equal to the return value. Sorry, the result balance should be equal to the return value of the function. So basically just making sure that the balance, the token, the vault balance that is withdrawn is the same as it was intended to be. So we have another resource interface for a receiver. So this one up here, just to recap, the provider just exposes the ability to withdraw tokens. So this would be kind of an admin method. Like, you wouldn't want to give this one out to everybody. The receiver exposes the deposit method. So you pass it a vault, and it deposits those tokens into the vault that it's being passed to. And the balance interface just exposes the field for the balance. So this is where an external user could check the balance of this user's vault. So the receiver and balance interfaces would be the ones that you're handing out to the public, more so than the provider. So when we look at the actual resource definition, this is where we can actually see. So this is how it's done. The resource is defined, and then we put this little colon here, and we add a comma separated list of the identifiers for our interfaces. So once these are in place, then this resource will require all of the fields and methods that are defined in those interfaces up there. So each vault resource, like this is kind of the meat of the contract for fungible tokens, and the vault is going to control the actual balance. This is the one that supplies the withdraw and deposit methods. So this is where the tokens are primarily interacted with, and this is what the user would end up storing in their account. So each vault has a balance. That balance gets set when the vault is initialized, so when a new vault is created. This is where we actually define the withdraw method. So something that's cool that I actually didn't notice there is you don't need to define the pre and post conditions down here in the actual resource definition. It looks like if those are defined on the interface, then you can just put the actual body of the function in here and leave those out. So that's super cool. So this withdraw method is taking an amount, so that's a unsigned fixed integer value, or sorry, unsigned fixed value, and we're subtracting that amount from the vault's balance, which is also a UFix, and then we're returning a vault resource with a balance of the amount that we've withdrawn from the user's vault here. So returning that back, and that would be what we would then pass into another user's vault, or pass into another user vault's deposit method, and we would just add the balance of the vault that we passed in to the vault that we're depositing to, and then we would destroy the vault that was passed in. So this is another thing that we didn't see yesterday, but it's all part of handling a resource properly. So a resource can't just live in code forever. It needs to be moved somewhere and stored, or it needs to be destroyed. So in this case, we've pulled the token balance from that vault. That vault is no longer valid, so we're just going to destroy it. And that's it for our vault resource. So it uses all three required things. So we've got our field here, and then the two methods that are required by our interfaces up top. So then we have a method on the contract that just creates an empty vault. So this will return a vault resource with a balance of 0. We also have a vault minter. So this is a resource that would again be passed to like an admin account. We don't want any account to be able to mint tokens. We want to specify who has the ability to do that. And this creates, or this has a method here, another public. So you're seeing a lot of public methods, and this is kind of to again expand on yesterday a little bit. Just because something is called public doesn't mean people are gonna inherently have access to it. We're still able to control what people have access to at like the capability and reference level, typically by using things like interfaces, and we'll get into that a little bit deeper when we go into the transactions for this tutorial. So heading back down to the vault minter, this just provides a method to mint tokens. So it takes an amount, it takes a recipient's reference to their receiver, so just the ability to deposit the tokens. Then we increase the total supply, which is that first field that we declared at the top of the contract, by the amount that we passed in, and we deposit. So we're creating a new vault because the deposit method expects to receive a vault, and then we're depositing those tokens. So we're creating a vault with the balance of the amount that we passed in, depositing it to that recipient's vault, and that deposit method will then destroy the extra vault that we don't need anymore. So that's it for the the resources, the interfaces, the fields, and the methods for the contract itself. And everything we do at this point here is just initializing. So when we deploy this contract, we're gonna initialize it with a total supply of 30. Don't honestly know why we do that, but I'm sure it's important for this demo. Next, we're gonna create a vault with that balance. Okay, yeah, that makes sense. So we're gonna create a vault with the 30 tokens, and we're gonna store that in the storage for account number 1. So when we create that, when we deploy the contract, we're gonna create a new vault. We're gonna store it in the contract owner's storage. We're also going to create a vault minter and store it in the contract owner's vault minter, main minter namespace of storage. And then we're going to create a private capability for the vault minter, and we're going to store that private capability in the private domain with the namespace of minter. So that'll be cool because we can actually link in from account number 1 and mint new tokens. So that's it for the smart contract. I'm just going to clear this console and deploy it. Make sure everything goes swimmingly. So it's deployed. Cool stuff. So one thing from last stream, I realized that my face was covering the actual signers. So when I was signing and deploying the transactions, or signing and sending the transactions, I was managing them through this little interface here. So I apologize, there's really no easy way to go back and change that, but I just wanted to make sure that you could see that for this example, because it is pretty important when you're trying to use the playground. So for our first transaction, let me just have a quick read through here. Yeah, so it's going to create a capability. It's linked on the account's token vault. The capability is restricted to the fields in the receiver interface, so it can only be used to deposit funds into the account. So this is going to be run with account 1 because it's the only one with a vault. And let's actually run through it before I send the transaction like a genius here. So we've created the transaction. We have a prepare block. So this is where we grab the signer account. This is the public object for this signer account, so we have access to this link method. So we're creating a capability. We're using a bit more of a special syntax now that we're using interfaces. But yeah, we're linking a capability to the receiver and balance references from the main vault in storage to the public main receiver namespace. So just to touch on this, yesterday what we were doing was just basically this. So we're just creating a reference to the resource itself. By adding these curly braces and these interface names, we're actually creating capabilities to these interfaces specifically. So this capability would not include the ability to withdraw tokens from this vault. So happy little log message to let us know we achieved greatness. And then we have a post condition here which just checks. So we're going to check the capability and make sure that it contains a reference to the interface that we want. And if not, we're going to log this message out to let us know that we failed. So this is a pretty straightforward transaction. It's going to run. So we've created the ability to deposit tokens to account 1's vault, and we've also created the ability to check the balance from an external account. So this is really important stuff. Like, this is where I would spend, you know, as long as you possibly need just to understand what's going on here. Delete some things from this, try to run the account or try to run the transaction. Just keep working with it until you have a full grasp of what's going on, because creating a resource, saving it to storage, linking a capability, and borrowing a reference are going to be like the 4 patterns that you continually use when working with cadence and flow. Seems a little daunting at first, but it becomes pretty comfortable pretty quickly. So let me just check our script here. This is going to be, yeah, cool. So that'll be the script that we run at the end, just to check the balances and make sure everything's run well. Cool. So transaction 2. This is where we set up vaults for the accounts that don't already store the smart contract. So again, we're going to import Fungible Token from account 1 where we've stored the contract. In our prepare block, we're going to first create an empty vault. We're using our move operator, storing that in a variable called vault A. We're saving that, the entire vault. So notice we're also using the @ symbol here to represent the actual resource and not a reference to it. And we're moving that. So again, I didn't point this out yesterday, but even in this method, the first argument here is the resource itself. And even when we're passing it into a method, we're using the move operator to represent a resource. And we're saving it to the main vault namespace in the account storage. So that'll give us a happy little log to let us know that we've actually created a vault and stored it. Next step, we're going to just link another capability to the exact same interfaces that we did in the last transaction. So we only want to link a public capability to the receiver and balance interface for the Fungible Token vault that we're creating a capability to right now. So we're going to target those from the main vault namespace that we just created. And we're going to store the capabilities in the public domain under the main receiver namespace. Happy little log message. Again, we're going to do an identical check to the last transaction where we check to make sure that there's a capability in the domain that we're looking for in the public storage. We want to check that it's the right type. So we want to make sure that there is a receiver interface in our reference to the token vault. And if not, we're going to log out an error message. So we can run this from any account that doesn't already have a vault in storage. And it'll run successfully. You'll see if I try to run it again, we should get an error because I've already stored resources in those storage domains. Which is totally cool because we only need one vault. So I'm just going to create vaults for everyone. Right now I'm just using a single signer for the transaction. So moving the old one out, putting the new one in, running the transaction. We're just going to stay simple for now. Okay. So everyone has their vaults and their references. You should see them in storage here. This is, again, I just love having this. So this is a good example because we can actually see like the fields. So we can actually see that there's a field called balance with a type of ufix64 and its current value is 30, which is the values that we set up when we deployed the contract. So super cool. When we look at the other accounts, we should also see that they have a vault currently with a 0 balance. So that's awesome. We don't have that in VS Code. I love it. It's a great way to actually stay on top of what you have deployed and check values without having to run a script every time. So it's great to see it there. Okay, so transaction 3. So we're gonna mint some tokens. So I've just switched the signer back to account 1, and the reason I've done that is because account 1 is like the admin in this case, and it has the actual minter stored in storage. So if you check any of these other accounts, you're not going to see a minter. And minters are pretty important when it comes to minting tokens, I must say. So just as usual, we're going to import the Fungible Token contract from account 1. So this has to be done even though that we're signing this with account 1. We still need to know what we're dealing with, where it's coming from, what things are called. So this helps us actually find these objects and resources in the Fungible Token code. So we create our transaction. First thing we're going to do is we're going to declare a local variable for our reference to our vault minter. So not an @ sign, we're using an ampersand. That means we're using a reference. Next thing we'll do is declare a local variable for our receiver reference. Sorry, just trying to figure out why that's let and that's var. I think they could probably both be let. We'll just keep it as is for the example. So now we have a prepare block, and in our prepare block we are taking our signer's public account object, borrowing a reference to our vault minter directly from our storage. So what this is doing here is, I don't have the actual term for it, but it's basically checking to see if this exists. If it doesn't, it's going to say no, we couldn't borrow a reference to the minter. So this double question mark is basically just saying do this, otherwise do this. I'll leave that there for now because there's a confusing thing that I was going to talk about, but we'll talk about that in a different stream. So now we're going to grab the public account object for our recipient, which in this case is going to be account 2, and that's going to give us the ability to get the receiver capability. So we're going to make sure that exists. We're going to use the force unwrap, and in this case, if that doesn't exist, it's just going to revert the entire transaction. So yesterday I was saying we're going to kill the code. I'd prefer to call it reverting the transaction in this case because it makes a little bit more sense. When we revert the transaction, that means that anything that's been done is kind of nullified. No tokens change hands, no resources are moved around. Everything goes back to the way it was before the transaction was run. That's really what happens. So I mean, if a transaction fails or errors out halfway through, it just reverts, and that way, you know, nobody's out any money or assets or anything like that. So we're doing that here. If this succeeds, we'll carry on. If not, it'll revert. Now down here we have the receiver reference. So we're borrowing a reference to the capability that we've stored up here. The reference is for our fungible token receiver. And again, if that doesn't exist, we're going to panic and just say that we couldn't borrow the reference to the receiver. So in our execute block, this is where we actually do the minting. So you'll see our minting ref should have a method called mint tokens on it. The amount we're going to mint is 30, and we're going to send them to our receiver for account number 2 and log out the result. So I'm just going to clear the console out so we can see the message a little more clearly. Again, we're going to sign this with account number 1 because it is the admin. This is the only account that has the ability to mint tokens because it stores the minter. Account 2, we don't need to put into the actual signer on the transaction because we've just basically hard coded in the fact that we're going to get the public account object for account 2. So when we run it, 30 tokens have minted and deposited into account 2. And when we check storage for account 2, we'll see that our balance is updated. So good to see that. Love it. Cool. So what are we doing here? So this is a transaction to send tokens from one account to another. So no minting, just sending. So again, import our contract from account 1. In this case, we're going to create a temporary vault. So @, we're actually using the resource. We have a prepare block where we get our signer account and borrow our reference to our vault from main vault and storage. Just one way of doing it. If we had a capability linked, we could pull it from public. But we want access to withdraw as well, which we're going to do down here. So we're just going to pull the reference to the entire vault from storage with no restrictions from the interfaces. We're going to withdraw an amount of 10 tokens from the vault. We're going to move those tokens because remember, withdraw returns an actual vault. So we're going to use our move operator, and we're going to store that vault in our temporary vault local field. Sorry. And in our execute block, we're going to get the public account object for account 1. We are going to get the capability for the receiver interface. We're going to borrow our reference to the receiver. We're going to panic if we can't get it. And we're going to deposit the tokens from our temporary vault into the receiver. And then we're going to have a happy little message when it's all done. So this should be account 2. And we did it. We made magic happen. Cool. So just for example, if we try to run this transaction from an account with no tokens in it, underflow, that's a sweet error message for flow. So really what that's saying is there's there aren't enough tokens to complete the transaction. So pretty cool. We have moved tokens from account to account. We should see that account 1 now has a balance of 40. Uh-oh, there it is, 40 tokens. Account 2 now has a balance of 20 tokens. And this script is just to read the balances of both accounts. So let's just run it. Oh, it says what we thought it would say. So that was a pretty fast and furious run through the Fungible Token tutorial, but I mean that's really all there is to it. It's a pretty simple example. Really, like, the focus is just on those 4 steps. So creating a resource, storing a resource, linking a capability, and borrowing a reference. Once you get that down, that's, you know, the workflow for building smart contracts in Cadence. So the cool thing to focus on here is interfaces, understanding what they do, how they help like restrict functionality, as well as kind of help you piece little items that you need for your resources together. Just spend some time with this one. And, you know, again, so transaction 3 here, you can change this up to account 3 and run that. We can mint tokens for account 4 and run that. These are all being signed from account 1 because account 1 has the power to mint. But now each of our accounts will have tokens in storage, and you can go through transaction 4 and start changing up, you know, where do I want to send these things, right? So now account 1 has 40 tokens, account 4 has 30. We're going to send some tokens over to account 4 from account 1. Now account 1 has, or sorry, now account 4 has 40 tokens, and account 1's back to 30. So just like play around with it, get an idea for how the tokens transfer around. Read through the comments, really understand what's going on at every step before, you know, stepping over into the non-fungible token tutorial. But this is where things actually became pretty real for me. Like, I really got excited when I actually started moving tokens around and you know, doing blockchain things. So this will be it until Tuesday next week. Tuesday we're going to do the non-fungible token walkthrough. Until then, please leave any questions or comments in the comments, and definitely recommend jumping over into the Flow Discord, getting engaged with the team, introduce yourself, and ask any questions to the people that built this stuff, because they're great and extremely responsive and really interested in what you have to say. So thank you very much for watching, and we'll see you on Tuesday.